Okay, this is going to be another very niche video on map lambdas. So not a distance or like steps on a maze lambda, but an arrow lambda. So I previously had an arrow lambda, but it was a little bit clunky, didn't solve very hard cases, namely stuff like Lana on ice where you're bouncing around. And then we had one at the UK finals where again, you were bouncing off the walls of a map. And you had to kind of trace where you were going to go. So I wanted to rebuild my map lambda to make it a little better. So let's pretend this is a map and this is a river. I'll show why that's important later. But the essence of it is we can say move on map from a start cell with an arrow. So let's use just an up arrow for now. And it's just going to tell me where I go. So from E4, if I go up, I'm going to go to E3. I can also put in a multiple, so that's the next argument. So if I go up 3 times, I'm going to go to E1, which is here. If I go up 4 times, I would be off the grid of Excel. So if I go up 4 times, I'll just show you what happens. It will tell me, okay, out of bounds. However, as you can see, I could go out of bounds of my actual defined area here. So the way I used to handle that in the old version of this lambda is I would tell the lambda where the bounds are. So I would put the minimum row, maximum row, so it would say 224 and then the same for the column, but that was clunky. So instead I wanted to just add that my map is, I can just put the map in and then it will tell me, okay, now E1 is out of bounds of this map. I also have an argument right at the end, boom, 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 to show path. So that will show me where I go. So I go E4, E3, E2, and then out of bounds. So that's useful where you move around and you collect stuff. I can then say what's in the map and do collections and stuff like that. But let's remove that argument for now. We'll come back to it later. So my next 3 arguments are all kind of different versions of the same thing. So these define what to do when you go out of bounds of your map area. So I've got stop, glide and bounce and wrap around. So let's start with stop. So in that case, we just stop at the edge and don't go any further. If I use glide, then we would glide along the edge of the map. So let's use a different arrow. Let's use this arrow. So in this instance, instead of stopping, let's do glide, and let's do maybe 5 steps. So in that case, what will happen is we'll go like this and glide along the edge of the map. Let's just show you the last argument again to show the path. So we can see the path goes to J2, so that's correct. The next one we have is bounce. So let's turn bounce on. So now we go like in this direction instead. So let's just clear those out. So we bounce to H3, then I4, then J5. And when I have bounce on, or glide, I show the arrows as well, because I might want to know how many times we bounced or how many times we changed direction, and having those arrows there makes it easy for me to do that. What's the last one? So the last one's wrap around. So let's actually just go back to an up arrow and turn on wrap around just to make it easy to see what it's doing. So wrap around, I will go off the edge of the map and wrap around to here and start going up. And this works with diagonals as well. So I'd wrap around, come to here, continue going up, and so on and so on. Now the final argument which I haven't shown is this allow map condition. So let's say this was a river here. So let's just put that back to same color. So this allow map, I wanted basically the same activity to be able to happen, but off of blockers inside the map. So let's just turn those to 1s as if that's a river. So my allow map here is actually going to be where this is not equal to 1. That's the allowed space I'm in. So all I need here is a grid of the same size that evaluates to a true or false. So now from E4 going up, so where's my start cell? Here. We can't go up because there's a river in the way, and we can't wrap around on a river, so wrap around doesn't work there. The stop activity does work, so we'll stop and just stay in E4. Let's actually move this start down as well. So let's move it here so I can show some of the other activities. So E5, we're going to go from E5 to E4, then get stuck. If we go and turn on glide and put the arrow to, let's do this one, and let's put a load more steps. So let's put maybe 20 steps. So we'll go E5, F6, then to G7, and then we go to G8 like this. And then now that the map's not blocking us, we'll go to H11, slide down, and this is kind of the path we would take. And then bounce will work in the same way, so just turn bounce on. So now instead we're going to go something like this, and we'll also then bounce off this wall as well. So it's very flexible. Let's just show you what the lambda looks like, and then I'll show you couple of case solves because they'll be really quick. So it's quite simple actually, more simple than the maze lambda. So it's basically, this is just my setup of the map to show what's in bounds or not, and all of the row column reference numbers. And then this is where we have bounce or glide. So basically what I'm saying is, if I'm going with a certain arrow, like up diagonally, then I only want to check what's relevant to that. So I'm going up diagonally, kind of up right, I only want to check what's above me and what's on the right at each step. And then if those are out of bounds, I'm going to take either a bounce direction or a glide direction instead, and then I'm going to reduce along that, so I keep moving along the path until I hit that bounce. And then if it's not glide or bounce mechanics, it's much more simple. I just reduce it down by adding a row movement here and a column movement here, which is defined at the start. And then if there's wraparound, I just do some mod calculations to wrap around. And then I say if there's stop and I'm out of bounds, then just give me what I had before. And if I'm not out of bounds, do the move basically. So let's quickly show you a few cases. So I guess I'll quickly show the wraparound one because I haven't shown that yet. In Harry's case here, we're starting at Jack of Hearts, which is M16. So in one of these questions here, we have a bunch of arrows. So I want to just set those up quickly. So let me do that. Okay, so basically with this one, I'm just going to do a reduce along all these arrows because they're all different, right? I can't just put a multiple in. So I'm going to reduce with my wraparound along the card map. So I'll say reduce, my initial value is M16, which is where the arrow is, the Jack of Hearts is, sorry. My array is to X look up the individual characters here. In this, give me this, lambda A, V, move on map, A, V, and the multiple doesn't matter. The map we'll put in is here, and we have wraparound on, which is this argument, and that should be it. So that's going to tell me the cell that I go to, which is M18. So I can then just say address to contents, that cell on this map, so tell me what's in there. And I mean, it's still a bit of work, but it saves having to figure out all the mod stuff, and then I just wrap around with movements on a map. Now let's do Lana on Ice level 7, because this was quite a tricky one. So we have this frozen lake. So again, this is not like a map where we can go on the borders, so it's nice to be able to block inner things on the map. So that comes in really handy for this one. So I'm just going to block all the green stuff out. Let's just call those X or something. There we go. And let's set up level 7. Okay, so we have different arrows there, so let's just do a quick mapping table again. So for this one, we're gonna move on map. Our start is this cell. Our arrow is X lookup this value in here, give me here. And then what do we have? We have a multiple, let's just do 100 steps, for example. Our map is gonna be this map. So we have the X's in there. Boom, boom, boom. Our out of bounds activity is to bounce, so we'll put a bounce there. The allow map is actually this not equal to X, so that's not equal to X. That should be it really. Oh, that's not it, that's where we finish up. I actually want to show the path, so let's show the path, and then I can just say address to contents of all of this stuff in my map. So I can see, you know, the path with all the bounces. So if you're familiar with this question, you'll know how hard it was. I then just need to count the bananas. I actually need to remove duplicates, so I would just say, I'd probably just actually do this for one cell. And then say, if exists this in where we came from, and let's make that move down. And do blank, otherwise give me what's in the cell. So if we've been there before, then we'd start to get blanks instead, and then we just need to count the number of bananas there. So the answer should be 12. Count if this is banana, and sure enough, we get 12. There was a few more mechanics in this, like you can slow down, but it was very easy to add in once you can see your path. The whole difficult bit was spilling the path that you would travel in on that question. So yeah, obviously this can solve all the other simpler arrow cases, because all you generally do there is just give an arrow in a direction and see where you go and do collections. So I I probably need to start putting all my Map Lambda videos into a playlist because there's been quite a few of them now. But anyway, there we go. That was it. Hope you enjoyed.